polynomials. We're going to start by taking a look at dividing polynomials by monomials, keeping it simple, and then we'll move on to looking at dividing polynomials by binomials. And we'll look at that in two different ways. We'll look at using long division, and we'll look at using synthetic division as well on one example. The final thing we're going to look at is what about a situation where you have a remainder. And finally, we're going to look at that polynomial remainder theorem, which gives us a quick and easy way of finding the remainder every single time. Okay, so let's take a look at the very beginning. Okay, the first thing we see here is we see a simple division here of a monomial into a polynomial. Okay, and what you're going to be trying to see is for every single term inside the polynomial that you're asking yourself, how many of that monomial fit in. So to do that, you're going to look at the coefficient with the coefficient and the variables with the variables. Okay, so specifically this first one, 6x to the 4 y to the third divided by 3xy. There's a few ways we can look at this. Okay, and it's probably, I mean, it's possibly easier to write it out in a fraction form if that helps you. So I'm going to do that. I'm going to just rewrite this in a fraction form. Say 6x to the 4 y to the third plus 12x cubed y squared minus 18x squared y, right? And that's all divided by 3xy. Right. And recall now, when you have a division that looks like this, that you can actually break it up into 3 separate parts. Okay, so we can break this up into 3 separate parts. So we're actually going to do that. Okay, so let's take a look at what that looks like. So we're going to divide this up into 3 separate parts right here. Okay, and each one has the same denominator, right? Right, so now that we've broken it up, we're going to look at each one individually. So 6 divided by 3 is 2. X to the 4 divided by x, well, recall your exponent division rule, where you just subtract the exponent. So 4 minus 1 is 3, so that's x cubed. And y cubed divided by y is 3 minus 1, that's y squared. Okay, plus, there's our plus coming straight down here. 12 divided by 3 is 4. X cubed divided by x is x squared, that's 3 minus 1 is 2. Y squared divided by y, 2 minus 1 is 1, so that's just y. And our minus comes down. 18 divided by 3 is 6. X squared divided by x is simply x. And y divided by y is just 1. Okay? And just so that you see what's happening there, it might sometimes be helpful for you to say, well, 3 goes into 6 twice. X goes into x to the 4th, there, like that. We're canceling out one of each, so you can see hopefully that this is this is how this is running. Okay, so the exponents reduce for the variables, while the denominator cancels out completely. All right, so you'll see what's going on right there. Okay, and that's what's going on here. Okay, so that's hopefully giving you a rough idea, and this is just generalizing what the division is. Okay, so the second one here we're going to look at as is. Okay, and we're just going to look at each term individually, right? Each one has an a number and an xyz, a coefficient, an xyz, a coefficient, an xyz, and we've got a coefficient and an xyz in the lowest terms right here, which tidies this up really easily. So 4 goes into 25 times x. So x to the 4 divided by x is x third. Y to the power 2 divided by y is just simply y. And z divided by z is 1, so we don't write it. 16 divided by 4 is 4. X divided by X is 1, we don't write it. Y divided by Y is 1, we don't write that either. Z squared divided by Z is Z. Okay? So we don't need to write the ones because it's just multiplying times 1. It doesn't change anything, right? So now we see this is highlighted here. So 4 divided by 4 is 1. X divided by X is 1. Y divided by Y is 1. And Z divided by Z is 1. So this is 1 times 1 times 1 times 1. So we do have to plug in the 1 there. We don't have anything else to work with. So that's what dividing by monomials looks like. Let's take a look at when we divide by binomials, because this is a little bit different. Okay, I'm going to show you two methods for dividing by binomials, right? I'm going to start by showing you. I'm going to start by showing you the long division method, right? It might be the more straightforward method for you, and then I'm going to show you the synthetic method, which some people find a little bit easier, okay? So the long division method is simply like taking this polynomial, so x squared plus 3x minus 40, and what we're going to do is we're going to create a long division with this polynomial and divide it entirely by x minus 5, okay? Now when you're doing this, you don't need to look beyond the first term every time, but recognize that you're dividing by a binomial, so you're going to be crossing it over with two terms. So look at the first term in each, the polynomial and the binomial, okay? How many times does x go into x squared? Okay, well, it goes in x times because x times x is x squared. So it goes in x times. We're going to put this x here above the above its own term, its own degree of term, but also we're recognizing that this x minus 5 is being put into this whole x squared plus 3x. Okay, so if we multiply, and you'll see now, if we multiply x times x minus 5, we get x squared minus 5x. Okay, so that's multiplying x times x minus 5. So your long division rules is all about subtraction. Okay, so we're subtracting the x squared minus x squared gives us 0. And 3x minus negative 5x is like adding 5x, so that's going to be 8x. Bring down our 40, or negative 40 rather, and we do it all over again. So how many times does x go into 8x? Well, that goes in 8 times. So positive 8 times. So we put in our positive here. Goes in 8 times. And we go, okay, so 8 times x is 8x. And 8 times negative 5 is negative 40. And when we do this subtraction right here, we end up with 0. Okay, so we have no remainder. That's pretty straightforward and simple. Here is our solution is x plus 8. Right. So let's look at synthetic division. And synthetic division is a little bit different from long division. Okay. So what we're going to do here is we're just going to look at the coefficients. Okay. So we have here, first we're going to write down the coefficients. We've got a coefficient of 1 here with this, right? We've got a coefficient of negative 13 on this one here, and we've got a coefficient. We've got positive 12 right there. Okay. So now what we're going to do is we're going to kind of just draw this down a little bit, give ourselves a little bit of space, and we're going to look at how x plus 1, or how x minus 1, sorry, behaves with this.
Find the interruption with the student for picture retake. Go to the library, last name, letters.